In the vast expanse of our universe, one destination has captured the imagination of humanity like no other: Mars. For centuries, this enigmatic red planet has beckoned us with mysteries and possibilities. Now, as we stand on the brink of a new era of space exploration, the journey to Mars has become more than just a dream. It's a tangible goal within our grasp. In this documentary, we embark on an odyssey into the depths of space, following the pioneers and visionaries who are leading the charge to make Mars our next home. From the daring scientists and engineers pushing the boundaries of technology, to the brave astronauts who will one day step foot on Martian soil. Join us as we uncover the challenges, triumphs, and groundbreaking discoveries that await us on the Red Planet. Get ready to witness the accumulation of decades of scientific innovation and human ambition. This is the story of Mars, humanity's next giant leap. Before we start to look into the future of human exploration in space, I want to look back at a brief timeline of how we got to the moon so we can better understand what steps we've already taken and how this has led to the point where we look at the Red Planet and see a future for humanity. 20th of June 1944. Germany launches a V-2 ballistic missile to the height of 176 kilometers or 109 miles, passing the Kármán line and becoming the first man-made object in space. Even though this could be seen as a huge step in human history, I think it's very telling that the first suborbital flight achieved by humans was a weapon of war. It highlights our relationship with violence and how we often achieve some phenomenal feats whilst trying to kill each other. 10th of May 1946. The USA conducts its first research missions into space using a modified V-2 rocket to perform experiments into cosmic radiation. This marks the beginning of our presence in space in terms of exploration and discovery. 24th of October 1946. The first pictures of our planet are taken from space at approximately 65 miles up or 105 kilometers. Although of very low quality and with ill-defined features, this paints a picture of our place in the universe. The black backdrop, extending forever, invites more questions than it provides answers, like most good science should. For the next few entries in our timeline, I'm going to skip over a lot of the detail and mostly just highlight when each event happened. Otherwise we could be here for weeks discussing the importance of each event and what we learned along the way as a species. 20th of February 1947, fruit flies became the first animals in space. On the 19th of June 1949, the first mammal in space was a rhesus monkey called Albert. On the 4th of October 1957, the first artificial satellite in space, which was also the first human man-made signal to be sent from space. 3rd of November 1957, the first mammal in orbit was a dog called Laika. On the 4th of January 1959, the first rocket to reach Earth's escape velocity in an attempt to impact the moon. And on the 13th of September 1959, this mission was successful and became the first aircraft to impact another celestial body. On the 19th of August 1960, the first plants and animals to return alive from orbit. On the 12th of April 1961, the first human spaceflight was achieved by astronaut Yuri Gagarin. November 1962, the first flyby of Mars at 11,000 kilometers or 6,835 miles above Mars' surface. The 14th of July 1965, first photographs to be taken of another planet from deep space, and this was Mars. This takes us all the way up to the big one, that one small step for man that truly was a giant leap for mankind. On the 20th of July 1969, the first humans to land on another celestial body and thankfully return alive, which also led to the first photo of Earth to be taken from another celestial body, and the first space launch to take place from another celestial body the next day on July the 21st. As monumental of an achievement as this was, it's only one small step on our journey towards the Red Planet and the potential of a new home for our species. But before we look at the practicality of colonising Mars, we need to look at what it's going to take for us to even step foot on a target so far away. Mars is 140 million miles or 225 million kilometres from Earth. Compare this to the Moon, which is only 239,000 miles or 385,000 kilometres, you start to see where the challenges lie, and also why the idea of setting up a kind of pit stop on the Moon, as some people have suggested, doesn't make a lot of sense, as this would be like stopping at the end of your garden for a rest before going on holiday on the other side of the planet. So the first obstacle I'd like to look at is how long this would take. When NASA sends a probe to Mars, it usually spends around 5 to 7 months in space. But this is a flight with a relatively small payload and a low risk to human life. It's expected that a mission to Mars with a small crew and the necessary equipment would take closer to 2 to 3 years of flight time with current technology. On the face of it, 2 to 3 years doesn't seem too bad, until you factor in the issues of food, water, waste, and exercise, and they're just the surface level issues at play here. Just think back to any given 3-year period in your life, and how often you're unwell. Perhaps not things like a cold, as being isolated in space would most likely prevent illnesses of that nature, but more latent issues with your body that aren't contagious would pose a potential risk. Not much of an issue here on Earth, but when you're on a small craft being flung towards Mars, suddenly things like appendicitis, broken bones, heart and lung issues, mental health and cancer become impossible challenges unless you happen to have a fully equipped hospital on board with trained medical staff. For the most part, NASA goes to great lengths to make sure that all of their astronauts are a picture of perfect health, but some of these issues develop in people who have had no previous signs. With all of this being said, on the 25th of June this year, NASA will start its first CHAPEA mission. This stands for Crew Health and Performance Exploration Analog, and to quote NASA directly, "This is the first of 3 planned missions. NASA will use research gained from CHAPEA to determine how to best support crew health and performance while living on Mars during a long-duration exploration mission." And, during the CHAPEA simulations, crew members will carry out different types of mission activities, including simulated spacewalks, robotic operations, habitat maintenance, personal hygiene, exercise, and crop growth. To be as Mars realistic as feasible, the crew will also face environmental stresses such as resource limitation, isolation, and equipment failure. But of course, that's not all they have planned. NASA is leading a return to the moon for long-term science and exploration. Through Artemis missions, NASA will land the first woman and first person of colour on the moon using innovative technologies to explore more of the lunar surface than ever before. Lessons learned on and around the moon and activities like CHAPEA on the ground will prepare NASA for the next giant leap, sending astronauts to Mars. So it would seem NASA is well underway in tackling the issues that lie ahead for these missions when it comes to the crew and the challenges they'll face. But what about the craft? The first obvious power source is the liquid hydrogen that is currently being used, but this isn't cheap, as the most recent rocket to go to Mars costs in the region of $2.2 billion, and the expected cost of a manned mission with current technology expected to pass $600 billion, and that's if they expect to land in 2033, a mere 10 years away. To put that cost into perspective, the gross domestic product of Sweden was $586 billion in 2022. NASA is also looking into the possibilities of using either nuclear fusion to power the next generation of rockets, or methane. Both of these do offer a better solution to the problem in terms of cost and efficiency. However, they are both in early stages and require a lot more testing before they become a viable option for a manned mission to Mars. After doing some research on the NASA website, I did find an article regarding a new craft referred to as the SLS, or Space Launch System, which sounds as if it would use a more powerful exploratory upper stage to enable a more ambitious mission and a 105 metric ton lift capacity. And to quote NASA directly again, the SLS will be NASA's first exploration-class vehicle since the Saturn V rocket took American astronauts to the moon more than 40 years ago. It will expand our research in the solar system, launching crews aboard the new Orion spacecraft to explore multiple deep space destinations. A fleet of robotic spacecraft and movers are already on and around Mars, but to fly and land humans safely on Mars requires a next-generation spacecraft. Orion SLS will ensure it gets there. So once again, it seems NASA is on top of finding the solutions to all of these problems, but as of now, details are sparse and it's hard to pin down specific details beyond the planning stage. The idea of living on Mars has captured the imagination of millions, with promises for a new start, a way to do things differently, and a way to keep humanity thriving if anything were to happen to the blue marble we currently call home. However, if this is to become a possibility, we still have a long way to go. For example, we've yet to even return physical samples from Mars to Earth for detailed study. But as of 2020, we started the ball rolling on this process through NASA's Perseverance rover mission. According to NASA, Perseverance is taking the next natural step in Mars exploration. It's looking for places in the Jezero crater that were habitable in the distant past, asking whether life ever existed there and looking for signs of ancient life. Perseverance is also studying the evolution of Mars's climate, surface, and the interior of the planet. The rover is also testing technologies for future human exploration of Mars. In addition to these science goals, Perseverance has a unique goal of collecting and caching samples of Mars material for possible return to Earth. This is the first step of many before we can safely land humans on the planet's surface. As for setting up colonies, we have even more obstacles to overcome. Air. As it goes without saying, breathing on Mars is no easy feat. It would require a constant supply of artificially created oxygen. So how would we create this oxygen so far away from Earth? Well, according to NASA, it's a fairly easy process, using something called a solid oxide electrolysis unit, which is basically a fuel cell run in reverse. So by taking the local atmosphere and heating it to 800 degrees Celsius or 1700 degrees Fahrenheit, then by running the energy into the cathode and anode of the device, they can separate the oxygen from the other gases. As for making sure that we have access to this at all times, we achieve this with a combination of personal air supplies, such as oxygen tanks and masks that could be refilled at stations, as well as oxygen and climate-controlled environments, both fed by the electrolysis device. Habitat. Speaking of buildings on Mars, we'd need to invest billions in research and development for habitats for future humans. These would need to overcome several key factors that would mean the end for its inhabitants if they were to fail. These factors include no oxygen, extreme cold, low pressure, and high radiation. These would also need to create privacy for the people living there, minimise waste as there's no way to dispose of it on Mars itself, and offer sensory experiences for its inhabitants. These problems could, of course, be overcome, but it's a long process as we've yet to even figure out some of these problems for Earth's own residents, and we'll cover this point in more detail later in the video. Supplies. Some of the things that we'd need on the surface of the red planet could be grown or made locally, while a lot of other things such as technology and more complicated things would have to be shipped to Mars. As much as Jeff Bezos would love this, I don't see Amazon Prime being much help. It would take regularly scheduled flights from Earth, each one overcoming the difficulties raised earlier in the video. Communication. As of 2019, NASA introduced the Deep Space Network, or DSN. This is a series of antennas on Earth, orbiters around Mars, and the rovers on the Mars surface. This will make communication easier as we already have the basics set up. However, this isn't instant and can take anywhere from 2 to 24 minutes depending on how far Mars is at the current time. For the most part, ordering deliveries for parts or new crew equipment isn't an issue. However, for emergencies and direct conversation, such as troubleshooting repairs, this could be the difference between life and death. Terraforming. One argument that often comes up when debate of moving to Mars arises is terraforming. Although we understand this process pretty well and how we could achieve it, therein lies the problem. It would take thousands of years to carry out. It would involve replicating the chain of events that happened on Earth to get our environment to a point where it was sustainable for human life. As a long-term solution, it shows a small amount of promise, but it won't help us anytime soon. Now at this point of the video, I want to address something I'm sure a few of you are saying to yourself. Yeah, but Elon Musk, Jeff Bezos and Richard Branson. And I want to address that. These people are good at two things: big promises that lead to not a lot other than making money, and catchy sound bites for headlines. You should always keep that in mind when you listen to what they have to say. Yes, SpaceX has been instrumental in NASA's recent endeavours, and we should be thankful for that. But Elon Musk is a money guy and nothing more. When he says that over 1 million humans will live on Mars by 2060, He doesn't have a plan for this. He will smirk at the cameras and pretend he does, but this is nothing more than a plan to make sure his net worth creeps up by getting a good headline. For evidence of this, you need to look no further than his other ventures such as Twitter or X and Tesla. Both of these companies suffer from bold promises but lackluster execution and poor user reviews. This is not what we need when it comes to reaching Mars. Again, SpaceX is doing great work, but this should be attributed to the actual technicians that make real plans alongside NASA and not the person making bold claims to profit. With or without him, this would all still be happening, especially when you hear claims about how colonizing Mars would be an insurance policy in case something goes wrong with Earth. He's of course referring to disasters such as global warming or a mass pandemic, but I can't help but think that if Elon Musk, Jeff Bezos and Richard Branson put their space toys money into protecting our home, we wouldn't need such an insurance policy. It's all vanity projects for these people, and we should be very careful about who we turn to when it comes to the future of our race. There are some people on this planet that have secured the lives of literal billions here on Earth, and I can guarantee you've heard of nearly none of them, and almost none of them are by any means rich. For example, if you want to see a real hero ensuring our species' safety, Google a man called Norman Borlaug. I won't go into detail as this would take us away from the subject at hand, but I might do a video about him in the future as he was an idol of mine. So this is the part of the video where I'd like to include some other facts about Mars and space travel that I think you might be interested in, but didn't fit naturally into the script as I was writing it. Longest time spent in space. This record is currently held by a man called Oleg Kononenko, and he has spent a total of 879 days or 2.4 years in space. However, these are non-continuous days and it has been spread over 5 missions since 2008. This puts into perspective just how much of a challenge future astronauts will face on their way to Mars. Mars has seasonal polar ice caps. These are made from CO2, which means they're technically what we would call dry ice here on Earth, and are estimated to contain 3 to 4 trillion tons of carbon dioxide, which is no surprise when you consider the fact that Mars's atmosphere is approximately 95% carbon dioxide. The largest volcano in our solar system is on Mars. This is called Olympus Mons and is over 21.9 kilometers, 13.6 miles, or 72,000 feet high, and has been known to astronomers since the late 1800s. Since 1960, there has been over 60 missions to Mars. However, only 18 of these are considered a complete success, but have been carried out by nations from all over the world, including China, Japan, Russia, the USA, and India, amongst others. Mars is cold, really cold. The temperature on Mars is really quite low, minus 200 degrees Fahrenheit or minus 128 degrees Celsius at its coldest, and makes up one of the biggest challenges we would face when on the surface of the red planet. Now, I've outlined countless obstacles and hurdles that would need to be overcome before we can go to Mars, let alone colonize it. But don't let that get you down. One thing I've learnt while researching this video is that one way or another, it will get done. And for most of us, it will be in our lifetime, because as humans, this is what we do. We ask questions, then we look for answers. We dream, and then we seek to make it a reality. Ever since we first noticed that red rock in space and named it after the Roman god of war, we wondered what it must be like up there. But here in the year 2024, it is possible. I do firmly believe that we will see a human on the planet in spite of everything I've said. It's not a matter of if, it's a matter of when, because it might cost billions of dollars, it might take the collective brains of hundreds of geniuses, and might even mean that we have to overcome challenges we haven't even identified yet. But it's inevitable, because to quote the immortal Bill Hicks, we're a virus with shoes, and we'll continue to spread ourselves anywhere we can go, from the lowest depths of our oceans to the highest points on our planet, and even to our moon. So if you enjoyed this video, give it a like for me, and if you didn't, don't be shy, give it a dislike and tell me why in the comments below, because this is my second video and any feedback is welcome. That being said, the subscribe button is the best way to help out a channel, especially one as small as mine, so please give it a press and make sure you hit the bell so you can watch this channel grow with me. Thank you, and I'll see you in the next one.